Welcome to The Explainer. Today, we're going to pull back the curtain on some of the hidden math that drives billions of dollars in finance. And believe it or not, it all comes down to something as simple as a coin toss: success or failure.
Right. At the heart of these huge company-making decisions is a pretty simple question. What are the odds of something working out versus, not working out? Think about it. A loan either defaults or it doesn't. A new drug either aces its clinical trials or it fails completely. The secret to modeling these kinds of binary yes or no outcomes is something called the binomial distribution, and that's what we're diving into.
So, before we can start calculating any odds or making any predictions, we've got to understand the basic rules of the game. There are 5, and only 5, specific conditions that have to be met. When they are, you've got what's called a binomial experiment. Now, I know these rules might look a little abstract, a little textbooky, but they're actually incredibly practical. Let's make it real. Imagine you're a credit analyst, okay? You have exactly 10 loan applications to review. That's your fixed number of trials. For each one, it's either approved or rejected. Yep, 2 outcomes. Now, based on historical data, you know the chance of any one application getting approved, and that probability stays the same. So P is constant. And because each application is from a different person, one doesn't affect the other, they're independent. And finally, what's your job? To count up how many got approved. That's it. That situation right there is a perfect binomial experiment. This slide really hits home one of the most important rules. On the left, checking 30 loan applications. You know from the get-go that N is 30. You know exactly when the experiment is over before you even start. But look at the one on the right, surveying investors until you find 5 who own crypto. Well, how many people is that going to take? You have no idea. It could be 5, it could be 50, it could be 500. Because you don't have a fixed N, it's just not a binomial experiment. Simple as that. All right, so now that we know the rules of the game, let's actually build the formula we need to calculate the odds. I promise, it might look a little intimidating at first, but it's really just made of 3 super intuitive parts. The first piece of the puzzle is easy. Let's say you want 3 successes, and you know the probability of any single success is P. Well, the chance of all 3 of those happening in a specific order is just P times P times P, or, P raised to the power of the number of successes you're hoping for. And it's the exact same logic for the failures. If P is the chance of success, then Q, which is just 1 minus P, is the chance of failure. So the probability of all the other trials being failures is just Q raised to the power of the number of failures. Makes sense, right? Okay, but here's the really crucial third piece. Let's go back to our loans. Getting 2 approvals out of 5 applications, well, that could happen in a whole bunch of different orders, couldn't it? The first 2 could be approvals, or the last 2, or one in the middle and one at the end. This part of the formula, the combinations part, it doesn't calculate a probability. It's a counter. It just counts up all the possible ways you can arrange your successes and failures. And when we stick all 3 of those parts together, we get this really elegant formula. You've got the number of ways it can happen, times the probability of your successes, times the probability of your failures. And this one single equation lets us figure out the precise probability of getting any number of successes in our fixed set of trials. It's pretty powerful stuff. So we've got the rules, we've got the formula, let's have some fun with it. Now we're going to see what happens when we apply all this to some high-stakes, real-world financial situations. Okay, first up, let's look at a venture capital fund. They've just invested in 5 really promising startups. Now, they're not naive. They know from historical data that any given startup has about a 5% chance of failing in the first year. The big question for the health of their entire portfolio is this: what are the odds that at least one of those 5 goes under? And the answer? A surprisingly high 22.6%. Now, this number is a perfect illustration of portfolio risk. A 5% chance of failure for any one company sounds pretty low, right? But when you bundle 5 of them together, the chance that your portfolio takes at least one hit jumps to more than 1 in 5. And that right there is why diversification is so critical in investing. All right, let's look at another one. And this time, we're talking billions of dollars on the line. So historically, a big pharmaceutical company knows that about 30% of its drugs make it through trials. Then they try a brand new screening method, and all of a sudden, an incredible 9 out of their next 10 drugs pass. Wow. The question for investors is, could this just be a crazy lucky streak?
what are the odds of getting a result this good if the new method is actually useless and the true success rate is still just 30%? The probability turns out to be an astonishingly tiny number, 0.0000144. To put that in perspective, that is about a 1 in 7,000 chance. Now, imagine you're the one presenting that number to an investor. That is some incredibly powerful evidence. It tells them this is almost certainly not a fluke. This new technology really works, and it could be worth a massive, massive investment. So, calculating the probability of one specific outcome is amazing. But what about the bigger picture? What should we expect to happen on average? And maybe more importantly, how much should we worry about the actual results being different from that average? This is where the mean and variance come into play. And honestly, they are beautifully simple. The mean, what we call the expected value, is just n times p. That's it. So for a bank that has 1,000 loans out and expects a 2% default rate, they can expect, on average, 20 defaults. Simple. And the variance? That tells us about the spread, the uncertainty, the risk. A higher variance means more uncertainty, and that means more reason to worry about how far the actual number of defaults could stray from that expected 20. So we've built this whole amazing model, but you might have noticed it all hinges on one single crucial number, p, the probability of success. So, in the real world, where on earth does that number actually come from?
I mean, this is the essential question, right? This is what connects our clean mathematical theory to the messy, complicated real world. We have to have a way to estimate p based on the data we actually see. And the answer is this powerful idea called maximum likelihood estimation, or MLA. Now, it sounds super complex, but the idea behind it is just so simple. It asks, if you saw 3 out of 10 startups succeed, what's the most likely underlying success rate that would have caused that result? Well, a 30% rate, of course. For the binomial model, all the complicated math boils down to this wonderfully intuitive conclusion. Your best guess for p is simply the number of successes you saw divided by the number of times you tried. It's just the sample proportion. Beautiful. So let's just quickly recap our journey here. We started with a really simple framework for looking at risk, the binomial model with its 2 outcomes and fixed number of trials. Then we built a formula to calculate exact probabilities. After that, we learned how to find the average outcome we should expect and how to measure our risk around it. And finally, and maybe most importantly, we figured out how to connect this entire model to the real world, using the data we actually see to find the most likely truth. Seriously, this model is everywhere once you start looking for it. From A/B testing on a website to quality control on a factory production line, even election polling. So the final question I want to leave you with is, now that you know what to look for, a fixed number of trials with simple success/failure outcomes, where in your world do you see this powerful pattern shaping the results all around you?